And if you find there's a river that you're sampling, it's very useful if you can try and at least include this habitat. So if we took a look here at a rock, and we'll have a chance to look in more detail together later, and certainly what we catch here will show us what's on here. This is often where we'll find lots of really interesting things, mayflies, caddisflies, and things like that. So the technique we're going to demonstrate now is how to sample a rocky riffle habitat. So we've got our spot here, and you see where the water's tumbling. Inside there will be sort of brick-sized stones. Those are ideal and useful to look at. And Jean's going to demonstrate how he starts at the bottom and works his way up. And as he's doing that, he's turning the stones with his feet or his hands. Okay, and as he's doing that, the water's washing off the little insects that are the things we want to look at and catch in our net. And we're going to look at them later. Okay, so Jean's going to get into the river here. He's going to have got his gumboots on or his waders, puts the net downstream of where he wants to be. And then he stands upstream and he starts turning over the stones with his feet. Sometimes the river's shallow enough you can use your hands. Okay, so he picks a stone up sometimes, has a look at it. All the time he's got the net downstream of where he is, and he's washing it off with his hand there, helping just to dislodge the insects off the stone. And again, like we had before, useful to not just stay in one place for the sampling, but to do a little bit here, a little bit there, a little bit somewhere else. Always shifting around and visiting different areas. Sometimes it might be deeper stones and sometimes more shallow. Now, if you're going to do this a lot, quite useful to standardize, make a standard time that you would be collecting the stones sample. And typically the ideal would be 2 minutes in total. So it might be half a minute here, half a minute somewhere else, another half a minute over there, but 2 minutes in total of sampling your stones habitat. You'll be surprised how much is actually coming off whilst he's doing that, and we'll certainly see that in the sample trays just now. There's certainly signs of life in there, and we'll see more of that just now when we... Oh, lovely. Little flat-headed mayfly in there. Okay, that's looking good. And there's a little dragonfly. Great. All right, well that's our stony rocky habitat sample, and we're really going to look inside, see what's in that net just now when we get to the trays. The one area we haven't covered is what we call stones out of the current, and that would be a section just behind us here. Right, so having had a look at the stones in the current habitat over there, we now come up here to a section which is out of the current, and we're going to have a look at John doing a bit of sampling here for about a minute or so with some rocks in this little bit of a backwater, still connected to the main channel, but just sampling how he would go through and collect from the stones out of the current. So John, would you like to give us a go and show us? So again, we're looking for the cobble-sized stones that might be in here, things that you can relatively easily turn over with your foot. And he's running the net through there, having tumbled them over, dislodged the insects sticking onto the stones, and running his net through that water. Right, the next biotope, or the next habitat we're going to be looking at sampling, is what we call the vegetation. Now, we looked earlier and we saw on either side of the river, right edge of the water, typically we will find reeds and sedges, maybe some grass growing there, maybe some bushes hanging in the water. and onto those would be some very special, unique little insects that we want to look at. So we're trying here to see if we can find them in this vegetation along the side. So what we really want to do is, typically we would sample about 2 meters of that. Okay. Now 2 meters isn't just from here to there 2 meters. It might be half a meter here, because it's this sort of soft grassy vegetation, but across there might be harder reeds with slightly different vegetation. So we'd do maybe half a meter here, another half a meter over there, and then maybe go across to the other side of the river and do another half a meter there and another half a meter. So in total we'd do 2 meters. And the idea there is that we want to get the different, that idea of different suburbs. We're going to different areas on the river, sampling in those different areas and measuring the health and seeing what's there by way of little insects in those different areas. So Jean's going to now demonstrate how we would do a vegetation sample, bearing in mind it would be 2 meters in total, but are scattered around the river at different places. Okay, Jean, show us the 2 meters of... You see how he's got the net just below the surface? Okay, and he's using that net just below the surface, scraping it along and pushing it into the reeds. And as he's doing that, little things that are clinging to the reeds and the grasses would get dislodged, go into the water, and as he moves the net through, they would be caught in the net. Okay, every now and then he looks inside his net just to see if he's catching anything there, removes the debris, and he looks, giving us a thumbs up there. He's looking promising. So he's got some things that would typically be found in the reeds or on the vegetation on the side of a river. Right, so what we're going to do here is look at sampling the gravel and sediment, muddy kind of substrate or biotope. So what we're doing is we're looking for an area that's nice and still. When you get in with your feet or your gumboots or your waders, you'll feel quite soon that what it feels like underneath your feet is quite squelchy, okay, muddy. So you're looking for the right substrate first. And Jean's found some of that here, and he's going to demonstrate here how with his net, miniSASS net or just a SASS net, he's going to churn up the mud with his feet, moving his legs around, whizzing his feet through the mud. And what happens there is that into the water comes the little bugs and beetles. There's some dragonflies that live in the mud. They love that. They also come up into the water, and then we'll sweep the net through that to get the things we're looking for. Okay, Jean, do you want to show us? So, and you'll see as he's doing that, the water gets all muddy because that's the mud that he's churning up. Okay, and in there he sweeps through the net and catches the little guys that will have been caught and been brought up into the water column. So we do that a couple of times for about a minute or so. Yeah, look how dirty and muddy the water's going as he churns up the mud. Now the idea here would be we find a muddy patch here. We also might find another muddy patch somewhere else on the river. It's good to move around and sample all the different muddy patches. Right, and there's the sample. He's got the sediment sample or the gravel, sand and mud sample in his net, and we can put that into the tray and have a look at that just now, and we'll see what we found in this sample. Alright, so what we've done there is we've brought our sample up from the river in our net. We've tipped the net out into the tray. We've washed some water through the net. Now we're just going to have a quick look on the net to see if we've got nothing left behind. Can anyone find anything hanging on the net at the bottom there? Or have we managed to wash everything off? Okay, alright, so we've got everything we need from our sample, from the river, in our net, and now into a nice clean white tray. And this is our vegetation sample. Okay, and the trick now is to just clean up the sample a bit, help remove some of the excess vegetation, put that to one side, just clean it up, give it a shake in the water. Alright, well, let's have a look in here and see what sort of things we're finding. You'll find on your miniSASS sheet it has two parts. There is the identification guide, which is this sheet, okay, which shows all the different organisms, and you'll see that they're grouped together. So things like the crabs and shrimps are lumped together as one group, and that corresponds with your miniSASS score sheet. There'll be crabs and shrimps lumped together, caddisflies, snails, worms, and so on. So on the one side of the sheet we've got our what we're going to be looking at identifying. Okay. On the other side is a little identification guide, and that really just helps us that if one isn't sure about what the thing is, you can start looking at it. So for example, does it have a shell or not? If it's got a shell, you come down this way, and there's the snails. Okay. If it doesn't have a shell, it's asking, does it have legs or no legs? Okay. If it's got legs, you come down this branch, and it helps us go down these different branches of the tree, looking at different features. It's asking questions all the time. Does it have legs? How many legs? Is it 4 pairs of legs? 3 pairs of legs? Does it have wings? No wings? Does it have a tail? And these sorts of questions it's asking, and that all helps us to identify what we might have in our tray here. So that what we do now is we look at our sample and see how many different things we can identify that we can find on our sheets here, and then we'd note those on the back of the score sheet here. Alright, so let's break up into groups and work with our trays and see how far we get.
Okay, so some really big beetles.
Rather the other way around.
Yeah.
We're going to tip that into the
Okay.
You can see it on the side of the tray.
Where?
With my fingers pointing up.
Well, it looks like a stir fry.
Alright, so we're ready now to start looking at our sample and identifying what we found in there and scoring and recording what we found. So we've got our miniSASS data sheet over here, and on the back of it you'll see are the different groups that we've looked at, seen and identified, and their sensitivity score. But the important thing is to say, if we found one of these things in our tray, we would note it and tick it in this column here. Okay guys, so we've had a great day out on the river. We've been in the river collecting, sampling, looking at our bugs and beetles and insects and seeing the diversity of what's there and something of the nature of this river. What's really going to be useful now is taking our score sheets and just seeing what they mean. Is this river healthy? And this is really the exciting part, to see and understand something of this river and how healthy it might be. So I've just taken at random here one of the group's scorecard, sensitivity score, and the site information tells us that it's the 11th of May. The collector is Josh, who's sitting in the group there. It's the Mgani River, and we are sitting at the Mgani River above Mills Falls. Okay, We've now got his sensitivity scores ticked for the groups that Josh found, and we're just going to plonk those up on the board here and see what results we get and what they mean. So, okay. Right. Who are the mathematicians amongst us? Who can add all of that up? Okay. Any suggestions for that?
52.
52. Very good. Okay. So we've got a 52. That's our total score. How many groups were there? 1, 2, 3, 4, 5, 6, 7. Now we want to work out the average score. Okay. That would be the average of all of those. So it would be the total score divided by 7, and we get roughly 7 and a bit. 7 sevens are 49. It's not quite 7.5. Well, let's call it 7. So the average score, let's say it's 7. Okay, now this is really where we have a chance to really monitor and measure the health of our rivers. If we look at our score sheet, at the bottom of our scores there is the river category and also an ecological category. What does that result mean? And this is where we look up and we see 7 for a rocky type river, which is what we've got here, rather than just a sandy river. We've got rocks and riffles there, so it's a rocky type of river. It is, where does that score fit in? Where does 7 fit into those classes? Have a look. Is it greater than 7.9, or is it between 6.8 and 7.9? It fits into that category. That's the results, between 6.8 and 7.9, and that tells us that this is a largely natural, with few modifications. It's in good condition. What we've done with this miniSASS is we've managed to give the different groups, the flatworms, the crabs, the mayflies and so on, we managed to give them what we call a quality value or sensitivity to pollution. How sensitive are they to pollution? And generally, the lower the number, the more they are pollution tolerant. Okay, so something with a 3, flatworms, typically would be things that we find in more polluted water. But if we found something like stoneflies with a sensitivity of 17, we would only typically find those in really clean water, unpolluted water. And what we do is we don't just take one of them and say because we've got flatworms here, it's polluted. No, we rather look at the whole community of things there. And that's what we're doing here. We're getting the average score. And that average score, when we look at our table here to interpret the data, gives us the average condition. How healthy, on average, is this river? And this is where the magic continues, really, is that if we looked at a river here and say we had a river running down here and we happen to be over here on the river, okay, on the Mgani River below Midmar Dam, and we got a 7. Our result was a 7. We looked at our table here, that said it was good. Okay. We then spoke to somebody else who was looking at the quality of their river, and they were down here as the river comes through another part of town. And they would, let's for example say they might have found a score of 4. If we look at our results, our table here, we see that anything less than 5.1 on a rocky river would be very poor condition. So that would be very poor. So either ourselves or keeping in touch with other people downstream, that allows us to look at the health of this river and measure the health. Now this might be because over here we find that if we did some investigation, there could be a factory here or a sewage works or some other source of pollution, and if we investigated we find that in fact these guys are putting pollution, effluent or something into the water here, And if we looked at it there and upstream, we looked at the difference. What's fascinating is that these little bugs in the river, they are in fact helping us to detect and tell us something of the health and the condition of that river. Are there any particular questions there that any of you might have? Yes? Emily?
Now that I've completed my miniSASS form and I have my results, what do I do about it?
Okay, so you've completed it and you've got a 7 here, but you might have found that you had a 4, which indicates it's very polluted. Well, that's when you would sort of speak to, try and investigate where's the source of the pollution. Maybe take a walk up the river, see if there's something coming in at the side. Is there a big stormwater or a pipe which is broken and leaking chemicals or something into the water? Do those sorts of investigations yourself. Scout around, see what's happening. Speak to other people who might have been walking here or monitoring. And if you find the sources, then follow up, speak to the authorities, the people like the water affairs, environmental affairs type of people, and they will know the right sort of contacts. But then continue to monitor. Let the people know that you're actually looking at the river. Your environmental group, your school, an NGO, and say, we're looking at this river, we're concerned that it's a 4. The river health tells us that it's polluted, there's something wrong there. And use that information to put pressure locally and in your community to make things better. As we were saying earlier, the more that we pollute the water, the less that we can use it. So if it's polluted, we're not going to want to swim there, or go fishing there, or drink that water. So this is the thing. As it becomes more polluted, it becomes less useful for our society and our communities. Now the thing with miniSASS is that there are a number of options, and depending how technical and how enthusiastic you want to become or become, you would choose different equipment and also how much rigor you put into the method. As we looked and saw earlier, we could have a SASS net like this with about a 0.5 millimeter pore size. The net's not going to last particularly long, but it's still suitable to start with. Moving all the way through to this chap, which has got the standard 30 by 30 SASS opening with 1,000 micron or 1 millimeter pore size. So slightly more technical and precise in terms of what you would want to be sampling for. In the same breath, the full SASS 5 forces us to separate our different biotopes, our different habitats that we've been sampling, all the way through from the stones being kept separate, to being kept separate from the vegetation, to being kept separate from our sediment samples. Now that's SASS 5, and obviously the more rigor and the closer we make this thing to SASS 5, the more reliable the data is and the more useful that data. But if you simply just wanted to get into the river, jump around, have a look and see what's in there, then a small net, all the sample being combined into one from all around your collecting area, be it stones collected with your vegetation, all lumped into one sample net, it's absolutely fine. Throw it into your tray, have a look at it, and you'll get some feel of what's there, some of the diversity, some of the adaptations to life in the water and so on. That's perfectly acceptable, and that's still miniSASS. But as I say, those of you who are interested, want to become more involved, you may decide, let me go the whole hog, separate my biotopes, look at the different areas, use a proper net, right size, etc.
Right, at the end of the day, we have now done the calculation. We have identified invertebrates. We have seen how easy it is to collect a sample. I hope it was easy, guys. And we have really enjoyed ourselves. Thanks very much for your enthusiasm and participation, spending the whole day with us here. We thank the teachers and principals of the respective schools for allowing you to participate in this event. The DVD will serve for the benefit of the current generations and future generations and everybody in this country. So what you are doing it actually for the country. And I think the questions that you raised, like use of water for hydroelectric power, were very clever, brilliant questions. And it talks to us in terms of if you use water to generate power, your footprints on climate change are almost zero compared to the coal that we use to generate power in the country. But those are very interesting debates because South Africa doesn't have much water. In terms of rainfall, the average is around 500 millimeters per annum, which is not that much. So let's conserve and protect what we have as much as we can. It is your right to have clean water, as it is your responsibility to look after the source of that water. Thank you very much.